Today's video is about intermediate carboanions. Carbocations we have already discussed. Second type of reactive intermediate we call carboanions. So these are the reactive intermediates in which carbon carries negative charge. What are reactive intermediates? They are reactive, short-lived species which appear in between reactants and products in organic reactions. Once formed, they readily decompose into the products. Remember one thing, stability of the product depends upon the stability of the reactive intermediate. So I am here with second type of reactive intermediate. You can see CH3 carbon carries negative charge. It's called methyl carboanion. Methyl carboanion. Okay. Number second, I have named it 1 degree or primary because negative charge is present on primary carbon. And what is primary carbon? Carbon which has only one adjacent carbon directly attached to it. That primary carbon, that 1 degree carbon carries negative charge. Then 2 degree carboanion and 3 degree carboanion respectively, or it is called tertiary, and this one is called secondary carboanions. So these are carboanions. Now I will tell you how are they formed, how are they generated, in what situation, in which environment carboanions are formed in organic reactions. So formation of carboanions. Carboanions. So they are formed. Carboanions are formed when a nucleophile which is denoted by Nu negative, any electron rich species, that's called a nucleophile, nucleus loving, that attacks in the substrate where there is positive charge, that we call nucleophile. The electron rich, they are formed when a nucleophile adds to carbon-carbon double bond or carbon-carbon triple bond. So in alkenes there is one pi bond, and in alkynes there is one pi bond. When a nucleophile attacks pi bond in alkene or alkyne, we get carboanions like this. This is nucleophile. Now it will attack positively charged carbon or electron deficient carbon or electron deficient center where there is positive charge. But as we can see, there is no such positive charge anywhere. But remember, pi bond shifts. Pi bond shifts. Pi bond gets delocalized like this. This pi bond will break towards one carbon. When nucleophile approaches towards alkene, and this carbon will attain negative charge and this carbon will attain positive charge. And once this carbon becomes positively charged, this nucleophile attacks on this carbon like this, and we will get a carboanion. Carbon here, H, for example, here negative charge, single bond, H and nucleophile. So the result is carboanion. And last point of this video is, when pi bond shifts in presence of reagent, nucleophile or electrophile, that effect is called electromeric effect. Shifting of pi bond only in presence of reagent, electrophile or nucleophile, that effect is called electromeric effect. And electromeric effect is a temporary effect. It is not permanent like mesomeric effect or inductive effect. It occurs as long as there are reagents. If reagent is removed, shifting of pi bond will stop. Then electromeric effect is not observed. Thank you very much for watching. Subscribe to my channel and press the icon button.